So distance d, it is equal to minus 484.89 divided by the r. So d is equal to minus 1.49. Okay. So this 1.49, it is the magnitude of the distance from the point O. The negative sign, it indicates the resultant is actually acting on the left side of the origin. Okay. We have assumed resultant is acting on the right side, but our assumption is wrong. And the negative sign indicates that resultant is acting on the left side. Okay. So we can correct the given figure. So you can draw the corrected resultant diagram. So this is the position of the resultant. This is R. This is the perpendicular distance. So this is D, which is equal to 1.49. And this is the angle of resultant, that is theta. Okay. So now this system, it is the resultant system. Okay. Now we need to convert the given system, that is a resultant system, into a single force and couple at point O. Okay. That means we need to shift the resultant at the origin. Okay. So for that, the single force and couple system will be draw this resultant at point O without changing its direction. So this is the resultant, that is R. Okay. Its angle will be same. Just we have shifted the resultant from this point to the origin. So now when we shift the resultant at the origin, it will change the effect of the original resultant. Okay. And therefore we need to add one moment at this point. Okay. So now this system and this system effect will be same. This is called as single force and couple system at the origin. Okay. So what is the value of this additional couple which is shown exactly at the origin? So this couple we can find out. M is equal to R into distance D. Okay. So R is equal to 332 into distance D is 1.45. Okay. So this value will be same. It is minus 484.89. Okay. And this negative sign, it indicates, so this will be negative because this moment will be clockwise. So it is minus 484.89. Okay. And this is equal to 484.89 Newton meter, and direction will be clockwise. Okay. So this is the answer for the second question. Single force and couple at the point O. Okay. So note down the second problem. So in the second problem, a frame ABC is subjected to loading as shown in the figure. Replace the system by a force and a moment at point A. That means we have to find out a resultant, that is called as a single force. And then we need to convert the system into a single force and moment at point A. Okay. So we need to shift the resultant at the point A. So when you solve this problem, first resolve the forces which are inclined. Okay, so if you observe this diagram, then there is no force which is inclined to x or y axis. Okay, so all the forces, they are acting in the x direction or in the y direction. So your summation fx, it is equal to 200 Newton. So this is the only force in the x direction. So this is minus 200, and that is equal to 200 Newton in the negative x direction. Okay. Then summation Fy, it is equal to minus 300, minus 200, minus 400. So this is equal to minus 900, and that is 900 Newton in the negative y direction. Okay. So this is the summation Fy. So if you observe summation Fx and summation Fy, we can say the quadrant of the resultant, it is in the third quadrant. So this is the resultant, and this is angle theta. So R is equal to fx square plus summation Fy square. So this is equal to it is 921.95, and theta is equal to tan inverse 900 divided by 200. So it is 77.47. So this is called as single force, that is a resultant. Now if you observe the question, we need to replace the system by force and moment at point A. Okay. So first find out the distance of resultant with respect to the point A. So this is the point A given. So we can find out the distance of resultant by using Varignan's theorem. So you can use the Varignan's theorem. So it is summation of moment by all the forces about point A is equal to moment by the resultant about the same point. Okay. So you can draw the resultant system and then use the Varignan's theorem. So resultant system will be, so this is the given frame, that is ABC. And this is the moment point A. Okay. So right now we know the exact direction of the resultant. Okay. So assume so this is the direction of resultant. This angle is theta. Assume perpendicular distance from point A like this. It is D. So right now we don't know whether the resultant is on the right side or it is on the left side. Okay. So assume it is on the right side like this. So this is the resultant system. So use the Varignan's theorem, summation of moment is equal to moment by the resultant. So to find out the left hand side, observe this diagram. Okay. So write summation of moment by all the forces about A. So first moment is 300 Newton. It is passing through the A point. So moment will be 0. So moment by 300 is 0. Second is 200 Newton. Its perpendicular distance is 3 meter. So moment will be 200 into 3. And the direction is clockwise. That is the sense of rotation. So it is minus. Next is 400 Newton. Distance is 3 plus 4 meter. That is 7. So moment will be 400 into 7. And the sense of rotation, it is a clockwise. So it is minus. Next is 200. So 200 into. Now for 200 Newton, if you extend this line of action, then this is the perpendicular distance with respect to point A. Okay. So this distance is nothing but the 2 meter. And the sense of rotation will be, it will try to rotate the system in the clockwise direction about the point A. So it is minus. So this is summation of moment. It is equal to moment by the resultant. So R into distance D. Okay. If you observe this diagram, that is the resultant diagram. So this moment, it will be in the clockwise direction. So this is again negative. And then find out the distance D. So in the summation of moment, add this 600 Newton meter as it is. Okay. So 600 Newton meter, it is in the clockwise direction. Okay. So this will be plus 600 Newton, anti-clockwise direction. So it is plus 600 Newton meter. So distance D of the resultant is 3.47 meter. Okay. So to convert the system into a single force and moment, shift this resultant at the point A. So this is single force acting at point A. Okay. And then show the couple or the moment at point A because of this resultant. Okay. So this moment will be R into D. So this is M, it is equal to R into D. Okay. And right now it is clockwise direction. So this R into D is nothing but this value. That is summation of moment at point A. Okay. And that is nothing but the minus 3200. Okay. So minus means it is in the clockwise direction. So this value is 3200 Newton meter. So your final answer is, so this is frame ABC. This is point A. Resultant will pass through point A. So this is the resultant. So this is R, that is equal to 921. And there will be one moment because of the couple. So this moment M is equal to, it is 3200 Newton meter. Okay. So this is single force and couple system at point A. Okay. So I hope this problem is clear. How to convert a given system, that is general force system, into a single force and couple system at any given point.